Color Computer 3, Lesson 21, Part 1. This is about graphic lines and boxes. It's similar to what you can do in BASIC, which the H-line command that are just do this in our assembly language programs. We got a lot to cover, so I guess we're going to get started. Okay, what this is going to do is draw lines or boxes. Side product is one of the functions you'll be able to call is to just display any one pixel at any time on the screen anywhere. All right, overview. We're going to have two programs, two binaries for you, lines 320 or lines 256. 320 will do 320, 192 or 200ths. The 256 do height to 192, 200, 225. It's going to operate at D700 out of block 35 in task 1. Same as we've been doing with other things like we did in lesson 18 with the letters. Normal basic program is the same as we did for letters. We're going to get what's ever here at 4000, which is FFA2. We'll put our block hex 35 in there, and we'll do a load in on either one of the line programs and give it an offset of 8000. Okay, why 8000? Because it's going to run at D7000. We can't do a load in at D7000 because that's where disk basic resides. So that's where we put block 35 down there at 4000 to 5FFF. We add 8000 to where it would normally load, and that gives us a hex 15700, which you know we can only use go up to FFF, so we just skip the 1 here, and that gives us an address of 5700, which is kind of in the middle of where our block 35 sits. So we load it, it will go in at 5700, but when it comes back in upper memory, it will be at D700. Then we'll restore that and go on. Stuff we've been doing before, just to recap. And again, a recap of this here, we'll be running in task 1 all the time. We'll have our display screen in 30 to 33 and our block 35 where disk basic norm resides. We'll have our code up there. Functions that have a do line, a do box, do width, do speed, H set, H reset, get position. Okay, we'll go through each one of them and see what that means. All right, for to operate it, it has to have these in your program at D710. We'll just say arg D710, and we'll put our structure there. And you can call this whatever you want. I call this one a capital L-I-N-E. You can call it ABC, call it whatever you want, and just put this name of the structure. Here is the structure that's in the include file. Has 1 byte for control. Our X1 or coordinate, our Y1 coordinate, X2 and Y2 coordinates, our background color and foreground color. Okay, within the control bytes, you could have either horizontal, vertical, diagonal, box that we don't need that anymore. I got rid of that. It's just still there, but you can put it in there. It just doesn't do anything for you anymore. And a width of 1 or a width of 2 for the line width. Okay, to draw a vertical line. Okay, I've got an orange line over here. Now, believe me, on a color computer, it would not look like it does on the a Windows or a Mac screen. But this is one I just for this demonstration. So we want an orange line. We give it the foreground color. Give it 200 for our X1 and X2 coordinates. So X1 would be 200 pixels in from starting on the left side over here. That's about 200 pixels to get there. This, oops. It's all this test only, so that'd be 200 pixels in for the line 1, X2, and then line X2 be also 200 pixels in, 20 for line Y1 or the Y1 coordinate, come down about 20 pixels from the top, and 180 for the Y2, which would be down about there. That's our four coordinates, just like you do in BASIC, okay? And we load up A with the parameter underscore vert, tell it's a vertical line, restore that control, and jump to the code that's up at D700, and you'll get an orange vertical line. Same thing with the horizontal line. Okay, this is a blue one. Here's the kind of coordinates we're doing here. 20 in for the X1, 180 in for the X2, and the Y's are both 180, down 180, down 180. Control right, do a line, you get a horizontal line. Want to draw a box, is the same thing, just give it the coordinates. Here's the coordinates we got that would kind of fit the four corners of this blue line here. Blue line, background color, line width is 2. I wanted a double width, and go draw a box, and it will draw a box for you. Want a diagonal, same as the other ones, just the color, your X coordinates, your Y coordinates, diagonal. Put that in control, and go draw a line for you. Right, here's some notes in here. Drawing a line, a diagonal line, is a lot of code, a lot of cycles, because it's be okay if it's a 45 degree. It's pretty easy to draw and not look too bad. Getting into if you got 32 degrees or 47 degrees or 17, it's a lot of code. Would take up a lot of room up there. So what I did was I just take all these parameters, I look at all of them, make sure they're all okay, sort them all out the way they need to be, and pass them off to basic, and let basic draw the lines. It's definitely slower, but it was just a lot of code. So and the width, you can only use one. You can't have a double wide one. Just too much code, and it will be not this good looking. Again, on a Mac or on a Windows machine, this is a nice pretty line. And if you're seeing it on your machine on your color basic, it's all bumpy, but anyway, it won't look this good. Okay, lines PDF. Okay, if I could bring that up. Okay, got this document. You'll get it in the zip file. It's just a document kind of going over what we just looked at. So it's something you can always look at. There's the structure, the parameters, include file. This is where my includes are. You'll have to have, wherever you keep your includes, you'll have it. This is what you'll need, these two lines to get it going. Again, you can call it capital line, you can call it anything you want. Here's the thing you need for the basic program. And here's the functions, and what we just went over here is just another idea what they are. Get all the parameters, give it a control, either vertical, horizontal, or diagonal, and do a line or do a box. Okay, here's some of the other ones that I haven't seen yet. H set and H reset. Give it a column and a row, color, and jump subroutine is H set. It's same as H set in color basic. It's going to turn one pixel on the screen where you tell it. If you want to, or read it, if you want to clear one pixel on the screen, like you could do the same thing. Give it the same coordinates or any coordinates. Instead of a color, give it the background color. That's just like writing over the top of it with the background color, turning it off, just do an H reset. The width does not use diagonal lines. Load up either a 1 or a 2. That's the only two valid widths. And do a jump subroutine to widths. Speed, this is strict. I probably shouldn't even put this in there for you, because this was strictly for debug purposes. Normally it's zeros in there, and it just flashes on the screen. You put it slow, I mean it goes slow. After each pixel it puts on a screen, it does a deck on a loop counter of 1,000 after each pixel. So if you mistake it, ever turn it on, you'll probably want to reset your machine. Okay, we also have get position. This is where's the position. I want the address on the screen. Entry, X gets the column, Y gets the row, and it'll return the NY, the screen address, okay? So if you did row 0, column 0, which would be the upper left-hand corner of the screen, it would return 2000 because that's where our screen is sitting in memory. Remember in task 1, it's at 2000. So when you give it 100, 150, give position, it's going to give you in register Y the address on the screen. Now there's a note in here. Need to figure out if it's MSB or LSB. Okay, what that means is if you give it row 0, column 0, it's going to come back with 2000, which is this here's a byte here. Remember, this is two pixels in 1 byte. So it's going to come back with the address of 2000. If you get row 0, column 1, it's going to come back with the address of 2000, but it's this pixel, not this, but it's just there. So how do you determine which pixel to turn on? It's based on what column, whatever you give in the column here. You give it 1, 100, 206, 17, 40, whatever column in there, you look at that last bit in that column, okay, for odd and even. Okay, it's either a 0 or a 1 there where that question mark is. If it's a 0, it's even. If it's a 1, it's odd. Okay, and you'll have to use masking to put it into the correct MSB or LSB. If it's even, okay, you'd want to save, okay, the ones that, when you mask it, you'd AND it, that it would save what's in the LSB now, and then you'd OR back in there to get that. Likewise, it was odd, okay, you'd want to save the MSB and put it into the LSB. Okay, just in the past we've just done both. It was just easier as it was kernel long one. It was just do both pixels at the same time. Here it actually gets down to pixel. Okay, so much for. Okay, I just showed you the lines, the PDF. Okay, let's look at some code. Okay, disclaimer, all the programs you're going to get, there's 5 test programs, and they were used for my testing. I says bad code. It's not bad code. It works. It's just you may find funny stuff in there, like you may go down and find something that says branch always around a whole bunch of code. Skip it. It was part during testing for debugging. Or you might find something that branches to the next instruction, or stuff just looks out of whack. It's just I didn't clean it up, or optimize it, or nothing. It was just my test programs you're going to get. Another note, some programs ask for fast or slow. I recommend fast. If you want to see what slow is, only try it on this test program here. Okay, and here's the 5 test programs, lines 2, 3, 4, 5, and 6. What happened to 1? 1 was very rudimentary just to get something going on. It kind of morphed into 2, and each one of them was further test it out. Okay, so one more screen. Okay, this is test line 2. I know it's not very exciting, but it was the first test program. I wanted a box 2 lines wide at these positions on the screen, light blue. Then I wanted a red line, horizontal line, 2 pixels wide at here. And then I wanted a yellow line, a vertical line from here down to here. Not over exciting, but I wanted to make sure that I got the exact pixels on there. So it was a simple program, it was 2. So let's take a peek, if you will, at that code. Okay, lines 2 list. Okay, it's kind of like we've seen on lots of other things, a lot of notes I put in there. And we got a bunch of includes. Okay, here's the includes. When I'm at home, I call it home use. Where I'm at, here's where all my include files are. Okay, they're here. I got them all asterisked out, and I've copied them all into the file you're going to get. Okay, the same names are they're just included right with the source code. The MacLab, the letters, lines, they're all there together. Okay, and by the way, the letter stuff we did in lesson 18 and the lines, they work in the same block 35 in high memory, so they're together and they don't talk to one another, but they're both up there. Other just normal stuff here. Beginning address is 2000. Here's the length of the screen. It says there's the end height and width. Okay, for letters, you need the statements here at D20, and for lines, you need the statement here at 710. Again, I call it line. You can call it whatever you want. Here was that speed byte, which I didn't take out. And here's the coordinates I use for box testing. I just come up with nothing exciting names, just box X1, Y1, X2, and what coordinates I used. And for line testing, here's the coordinates I'm using. Now here's our background color. I got the black, and foreground color is really not, well, it's used, but not that much. I just said white here. Place to save our stack, and then our program, like we've seen in the past, to do some normal stuff. Get into task 1. And this here's a change I'm making to all my programs, and you'll see it in some test programs from now on, is give it the background color, because both the letters from Lesson 18 and lines here will use this here. And this here in A, I'll put the register, that is the background, okay? And it's the one we call black, so it's register 0. So remember, this is a register. And one of the very few times you'll ever see the actual color used. Almost everything uses the register, not what the color is. But for the border, the system wants the actual color, and we're doing a black one here. It makes it kind of odd because they're all both zeros. If, like, say, the border wanted it to be white, that would be a 3 after instead of a 0. Then we'll get them in there and we'll do it in this system. So let's go down and look at the init system. That's kind of a few differences in there. Okay, excuse me. Anyway, it says come in with them 2 things in A and B. We'll push that in a high speed, store our palettes, clear our screen, just normal stuff. Our graphics mode, okay, which in this test one here, we're using 7A, and here's the different ones that I use, 1A, 2A, so on and forth. So 7A is 256 by 225/16. So we get into graphics mode, we'll get our colors back up, we'll store register B, which is a color, actual color number, into a thing called H border, which is the MMU uses to paint the border. And we'll store our background color in a field name background color. And here's a note here. If used in letters below, do this, will be defined. What that means is if we're doing both letters and lines, and inside the include file of letters, it has a field called, or do letters is defined. So it says if def or if defined do letters, drop this code out. Well, it is, we're doing letters, it does drop this code out. It stores the background color in the LSB 11, it will multiply it, so it puts that background color in both pixels. We'll store that in a thing called background both. Then it will AND out to get the MSB. And what that means is here we got the LSB that we'll be able to use for masking. The MSB for masking, like I talked for, are both of them in there. So that gives us our mask to use for the background color and letters. All right, go back up where we was. We've knitted it. Here's just the normal stuff from here on out. This was that speed. It's not important. Okay, we're going to do what we did in letter 18. We're going to draw something. We're going to draw the size message in the lower left-hand corner of the screen with do message. Our test box. Okay, we're going to use some parameters. I said we would up here. We'll use these parameters. Okay, we'll load box X1 and store it in line X1, box Y1, so on and so forth. There's our 4 parameters for a box. Give it a color of the register __ light blue, stored in foreground color. Load that background color we just talked about into background color. Line width of 2, jump subroutine, do the width, and then draw a box, and we'll have a light blue box on the screen, which I showed you in that sample before. Line testing is the exact same thing. There's the parameters. Tell it's a horizontal line, width of 2, red color. Put that in there and draw the line. Or we had to do our, we had to do a vertical and draw, no, we did that with horizontal. I'm getting confused. Okay, now we want to draw another another line, a yellow vertical line. So we do vertical and control. I put a here. This here's my testing. Okay, load A4 and jumpers do width. Width only takes a 1 or a 2. If you give everything else a 0, a 3, a 9, a 12, it's going to just say that's no good, and it'll default you to 1. So I put it in there to make sure that worked. Here's our yellow color, and here I changed the parameters. Okay, I'm putting an 80 for the X, which is like from starting here, it's 80 in for both of them. It's kind of towards the center of the green. And normally you'd have your own parameters, but I was trying to get the exact pixels, so I used the line parameters from above and just added 1 to it so I could be 1 pixel different. And here I wanted to be 48 pixels there just to make sure it was come out right. Here we draw our vertical line. Here we put another message on the screen, our press any key message. We sit here and do this quick loop for any key you press on the keyboard, just waiting for you to press a key. Then we'll erase our message, because remember from lesson 18, all we have to do is say erase it, because the last thing we did in message was all this stuff here. None of this changes. It's static once you put it in there. Go to 1, tell it to erase it, it will erase it. Likewise with the last line we put on the screen, which is the yellow vertical line. So down here what we'll do is we'll change the background, load up the background color and store it in the foreground color, and say do a line. It will erase that last line we put on the screen. The rest of this is normal stuff. Put an end of job message on there, and press it, queue message, I believe it is, the messages. And here's something that we're doing different here. You know, in the past we've been changing all these MMU registers, block 35, and the last one we did with the example, the Mickey Mouse screen. Okay, we was using block 20 through 23 in task 0. Well, there was another macro out there I use called task X. And what that does, it will load X with this address here up in upper memory and jump subroutine. And this goes right into basic, and it will restore all them things that you manipulated around, whatever you've done to any MMU register. This will straighten it back out for you. The only problem is that normally is not a problem, is it will turn interrupts back on, and you can turn them off right away. Now, beware, if you're doing you don't even need to do that really in this program here, because I'm not doing them with the interrupts. The interrupt vectors have stayed the same. If we was doing something like with the timer and you move the interrupt vector to someplace, just say you moved it into that block 35, the code, you'd be wiped out by the time you got back, or you couldn't turn it off quick enough. So anyway, just be careful if you use this here. Then we go back to task 0, wait for key press, look for the queue, and do our normal end of job stuff, and we're done. Okay, so much for particular screen. We can move on and look at some of the other tests, what they would look like. Here's test number 3, I believe. It's a bunch of boxes. It has a good effect when you're watching it there. And what I did for testing there was each one of these boxes of coordinates, all 4 corners, were done with random. So therefore everyone is different, and that was to ensure that I didn't have any problems. Let's just say you got X1 and X2 were both 10, and Y1 and Y2 was both 10, what would happen, okay? Or if one of them, it was just make sure there was no problems with the code. Here's the next test, just putting, turning pixels on the screen. I think it asked you some parameters, 1, 2, 3, 4. I think it was 256, 512, 752, and 1024. Number of pixels put on the screen, just for my testing. Another test was drawing this line, this yellow line here, and then it would erase it, move over 1 pixel, display the yellow line, erase it, move over 1 pixel, and just go on all the way, well, as far as you tell it to, you know. And I stopped it here after this here, and it goes going across or anything on the screen. Just say it has kind of a background, it would erase it. As you can see down here, it started erasing our message we had down here. So I thought what neat you may want to try is if you want, you could have an image to display, and as it went across the screen, every time it moved over 1 pixel, you could put that line. You could put one line of your image on the screen. So when you went across there, you'd end up having your image on the screen. Something to try. Okay, and this one here, it starts out with yellow lines, and it will draw this outside line here in yellow. This top one here in yellow, come in, draw this one in yellow, this one in yellow, 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 and keep going all the way down until it got all the way down here, all the yellow lines. Then it pops back up to the top, and it starts with light blue, this line here, this line, this line, this line, this, so on and so forth. It continued to work its way down. Well, when I stopped it, just so happens I caught it right here. If you look right there, you'll see it goes from yellow to blue. That's when it was, as the time it was going pixel by pixel down there, just changing it to blue. So go down, finish with the blue, then I think it goes to red, then it might go to green, and then orange. I don't know, maybe 5, 6, 7 different colors. It just keeps going through there. And then I think at the end it starts up at 0, 0 and goes down to somewhere down here and puts a blue line in there. Anyway, we'll take a look at that. Okay, take time to demo a few programs. Okay, let's kind of do that. Let's see if we can. Okay, good. Let's run that first test. They say run to want to load the programs. Yes, the first time we'll just say yes, it will load the programs. Like I said, in block 35 and low memory, and block 35 slow or fast, we'll do fast. And I believe if you just enter, it defaults to fast. And we'll just execute that. And that's all it does. Okay, it just does that. You don't have to remember my first test did all that stuff worked. When I hit the space bar or any key, it's going to erase the yellow line. And we're done. Hit Q and we're done. Let's run it again. Let's do slow. Oops. No, we don't need to load them because we already did. Let's do slow. And you'll see what I'm talking about. It goes slow. If you were doing a whole bunch of lines, it would take a long time. Again, this was for debugging purposes. I could watch what was going on in this test program. Later ones, once I had it all proved out, I didn't really need to do any more slow stuff. I just never took it out of the programs. There, press any key. Now if I hit spacebar again, it will erase the yellow line. And bang, we're done. Let's run another one. Again, it's going to ask us, oops, put the right program name in there. It works a lot better. And that's not the one I wanted, but we'll do it anyway. Number of dots, let's just do 2. Let's just go put a bunch of pixels on the screen. Not too exciting. I didn't mean to run that one there, but this is what I meant to do. Yes, we'll load the programs the first time. Fast for sure. Number of boxes, let's just do 44. Has a good visual effect when it's drawing them on there. You can go up to 100 boxes. One more. Yes, we'll load them. This here has seemed to maybe a strange question to ask. Number of lines 1 to 42. Why 42? That's the most you can get across the screen. So we'll do that and we'll execute it. And there you go. It draws then the blue and some other colors. It just keeps changing colors as it runs through there. And it draws that blue line from up in the corner down to there. So that is it. Okay, we've seen a few programs. Okay, we're going to get a zip file. We'll tell you where to get it in the comments below. Get a disk file, has all the binary, the basic programs, and all the binary programs you need to run all this stuff. You'll get the source code and the include files. You get everything. Remember, the source code is just my raw test programs. I didn't clean it up at all. And that PDF document that we looked at earlier. All right, what we're going to do in the future, we're going to have a part 2 to this. It has stuff that's not test programs, or a little bit more organized programs that we'll take a look at. I would include them, but I realized this was going to run way too long. Then we're going to do another lesson on includes and macro libraries. We did that in the past, but I'm going to go back over and do a little more detail on macros. If you're learning this stuff, some of the things are going to be really help you out and save you some time. I also built some default graphics startup programs for 256 and 320 pixels. I did that because I've been doing this for color computers since the early 80s, but assembly language programs since God, you can believe this, since the late 60s or early 70s. Anyway, I was in here lately, the past year or two, I've been just starting with a blank sheet of paper and saying, oh, I'm going to try that. And I'd start copying code in. So where did I do that? Let's say I did that in lesson 8, I believe. Well, no, I couldn't find it in 8. Maybe it was 7 we did that, or some other project I did. And I just get something, I'd copy it in. I'd copy something in from here. Where did I do that random stuff last? I'd copy it. And I was copying all this stuff all the time and digging out where's it at. So what I just did, stop. I built a program that was start up a graphics program with everything you possibly need to start it and get out of it. And in the center where the main is, you just put all your loops and everything you want to do in the middle, and when you're done, it will get you out and clean it all up and take you back to basic. Okay, I think it does is I think it's in the middle. I think it prints test program or something like that in the middle of the screen. Copy it, rename it, compile it, and you're good to go with most of the stuff you're going to need for just the basic stuff for both 256 and 320. And I also have a falling sand simulation program, which is kind of neat, but I'm not going to even get into it until I get the other stuff done. So that's going to be it. Okay, all the information and the links will be down below. Use them. Use the program if you want. Comments if you want. Likes or whatever. And again, that's it. Thanks for watching.